GS and GS students. Welcome again for a new video in chapter 8 electromagnetic induction. In this video, we will study the following objectives. First, to define or to define and to study the properties of a magnet. Second, to determine the magnetic field created by an electric current. According to a magnet, as a revision for for grade 11 S science sections, magnet a magnet is a metal that creates around themselves an invisible field called magnetic field. فإذا المagnet هو عبارة عن material أو عن metal بينتج حوالين نفسه field بنسميه magnetic field abbreviated as B vector. The SI unit of the magnetic field B is Tesla. A magnet has two poles, south and north. As shown in the following figure, we have two poles N and S, where N is the north and S is the south. When a magnet is cut into smaller pieces, each smaller piece is a new magnet having both north and south pole. So إذا في عندنا magnet نحن رحنا قطعناه أو قصيناه بالنص راح يطلع لنا new magnets, each one having S and N pole. The magnitude of the magnetic field decreases as we move away from the magnet. كل ما بعدنا عن هذا المagnet كل ما بنلاقي انه قيمة المagnetic field, the value او magnitude of the magnetic field decreases. The magnetic field lines enters from S a pole and leaves from N pole, as shown in the following figure. The magnetic field direction or the direction of the magnetic field enters from S and leaves from N, as shown in the following figures. Now we have to study the magnetic field created by electric current according to three cases. First case, magnetic field created by long straight wire. The magnitude of the magnetic field created by a current I flowing in a wire at a point M at a distance D from the wire is B equal to times 10 power minus 7 divided by D times the current I, where I is the current passes through the wire and D is the distance between the wire and the point. As shown in the following figure, we have here a point and we have a wire. This wire containing an electric current. There is a magnetic field at the point, at this point, and also for these points, this point, this point, and this point, this point. How to determine the direction of the magnetic field? We have to use the concept of right hand rule. Look for this video. So we have the direction of the electric current in the wire passes down. So we have to use the right hand rule where the thumb is the direction of the electric current and the other fingers is the direction of the magnetic field. So we calibrate our finger in order to get the direction of the current. So the other fingers give us the direction of the magnetic field. Okay, so in this case, we use the first situation of the right hand rule in order to get the direction of the magnetic field according to the right hand rule. So, magnetic field created by a flat coil, second case or second situation. So, if a current flow in a coil, a magnetic field B is created at the center of the coil such that, so this is a coil which is a circular connecting wire or a wire mainly used, we use the copper. So the we have to use the right hand rule, but the second situation. In this case, the four fingers give the direction of the current while the other finger gives the direction of the magnetic field. So the magnetic field, we can use the right hand rule, curl the fingers, the four fingers of your right hand rule along the direction of the current. The thumb indicates the direction of the magnetic field. The magnitude of the magnetic field created by a circular wire is given by B equal to pi times 10 power minus 7 N I over R, where R is the radius of this circle and I is the current, where N is the number of loops of this circular wire. Note, a coil acts as a magnet having north pole and south pole. So again, the magnetic field enters from us and leaves from us. So the magnetic field in this case enters from the lower face and goes up from the upper face. So we say that the lower face is south and the upper face is the north. The third situation, situation is the magnetic field created by a solenoid. If a current traverses a solenoid, then the magnetic field B is created at a point inside the solenoid such that the direction of B, we can use also the right hand rule as in the previous situation, which is the second situation. The four fingers give the direction of the current, while the thumb gives the direction of the magnetic field. So as shown, the direction of the current is up, so the magnetic field as shown to the left. And for this case, the current goes down through the solenoid, so the magnetic field goes to the right. Again, the magnetic field can be calculated by using the formula B equal 4 pi times 10 power minus 7 Ni over L. So by this case, by this formula, we can calculate the value of the magnetic field. According to the following video, again, we can notice that the following how the magnetic field can be drawn. So this is the direction of the current goes up in the solenoid. So the thumb gives the direction of the magnetic field as shown in the following figure. Okay, second case, if the electric current goes down, so we notice that the magnetic field goes to the right. So this is the direction of the electric current goes down. So the thumb gives the direction of the magnetic field to the right. Electromagnetic force. The electromagnetic force, a wire traversed by an electric current, is a presence in the presence of a magnetic field B, is subjected to a force F called Laplace force. This Laplace force also can be determined by using three fingers right hand rule. The first finger gives the direction of the current, the second finger gives the direction of the magnetic field, and the third finger gives the direction of the force. Again, look for this video in order to know how to draw this force. So the first finger is for the electric current, the second finger is for the magnetic field, and the third is by default for the force. So we have to calibrate our hand in order to get the direction of the current and the B, then the magnetic force by default determined. So again, now we have to determine the direction of the electric current. The direction of the electric current in the wire, according to the figure, moves in this wire by this direction, and the magnetic field given in this case up. So the force is given to the right. Again, so we notice that the direction of the electric current moves from the source in this direction. This is the electric current, so moves in the wire in this direction, and B is directed upward, so the force is directed to the right. So Laplace force have four characteristics: point of application, which is the midpoint of the straight conductor wire; line of action, the force is perpendicular to the plane containing I and B; the direction according to the right hand rule; and the magnitude can be calculated using the formula F equal I B L sine alpha. Thank you.